Hello everybody, my name's Dr. Ian Sandel. I'm one of the admissions tutors here for the Department of Electrical Engineering and Electronics, and welcome to the department. So if you'd like to follow me, I will take you upstairs to the lab and talk a little bit more about the laboratory equipment and some of the practical work we do here in the department. Okay, so welcome everybody to one of our undergraduate laboratories. So the laboratories are the beating heart of our department. On all of our programs, we offer a highly practical course. So you will spend a minimum of a day a week in one of our laboratories, either this one or our similar laboratory downstairs, or possibly one of our computer rooms. I say a minimum a day a week. In many cases, you'll be in these various labs for 2 or 3 days a week throughout the entire length of your stay with us. These will start as very structured labs during your first year, so that you understand how pieces of equipment work. We'll teach you how an oscilloscope works, how different power supplies work. We'll analyse simple components. How do diodes work, how do resistors work, and we'll build them up into simple circuits that we will then make into more complicated circuits and build up and up. We also have a large amount of scope for project work. In it, we have every year you will do various parts of projects. So in your first year, we put everybody together in a group project where you work in teams of 4 or 5, with every group striving to achieve the same project goal. And these are quite often themed around some sort of autonomous car. We're looking for you to design, construct and test some form of autonomous car. So this gives you an experience of working in a team environment, using different bits of skills that you've learnt throughout your lectures, building them into a practical content, and also giving you some industrial type experience. We try and set this up as close as we can to an industrial project. So we give you the task, that whatever problem we want you to solve, we give you a budget, and we try and leave you as much as possible to get on with that yourselves. We're there for support and guidance, but we want you to solve that. Because as engineers, that's what you're going to do after you've graduated. You're going to go out to the world of work, a client's going to come to you with a problem. They're not necessarily interested in what the solution is. They want you to solve it, and we want to see the different ways in which you can do that. Now, project work evolves throughout your second and third year, and by the time you get to your third year, you will take on your honours dissertation project. So this is an individual project that you will do with a single member of staff, and it will span the entire length of your year, and it's worth a quarter of your final year's marks on whichever programme you're on. These projects can be highly theoretical, highly practical, anywhere in between. There's a whole range of projects. Typically, we'll put about 300 projects up for you to choose, and you are then you're also able to propose your own projects if you don't like the ones that we give you on offer. And this is the lab where most of this work takes place. So then in your final year, you'll spend several days a week in this lab working on that project. And we have a whole range of equipment to help you with that. So every bench space has dedicated multimeters, oscilloscopes, power supplies. We also have more specialised equipment that can be used as well, which we'll go down and see shortly. Okay, so if you'd like to follow me along, so we've got a series of benches set up as we go along the lab. On the side here, we have some of our more specialised equipment. So we don't have one of these for everybody, but we have more expensive spectrum analysers, frequency meters and equipment such as that can be used in projects that can be made use of as well. And down here we have some more specialised equipment. So we have a VR suite. So every year we have several students that are working on developing their own VR virtual reality programs as part of their project. So we've recently had a student that has worked on developing a virtual reality tennis training system. So this becomes their tennis racket. It has a series of sensors built in here, and then the virtual reality environment they've created for that enables them to play tennis, and these track the movements, the positions, and it can be used for enhanced training performance, telling them they're hitting the ball at the wrong time, the wrong position, they're holding the racket wrong, and all that can be fed back to give improved performance. We also have a range of 3D printers here in the department. So some of these are used to produce parts for projects, so allowing students to create real-life prototype products by printing parts. And we also have what we like to call our hackable 3D printers. So these are 3D printers that students take apart as part of their project work and then look to repurpose for other means. So this 3D printer here has now been repurposed as a liquid dispensing robot. So we have placed a syringe on it. It is able to move around. It can extract different amounts of liquid and mix them together in different pre-configured configurations. And the printer to the side here is being developed to print out sugar-based solutions. So it could be used potentially in the catering industry to 3D print sweets and cakes. And on a slightly more serious note, a sugar solution to a first approximation is a very basic assumption of what all living cells are. So if we can print a sugar solution, maybe in 10, 20, 30 years' time, we could 3D print replacement hearts, replacement lungs. And that's the kind of work our students are working on here. So, as well as the academic support that you'll receive during your time here, we also have dedicated technician supports. So in all our labs, we have dedicated technicians that are here. They're here to help you as well, understand how the equipment works, to help you in problem solving when circuits don't go so well, and also helping you in using some of the more advanced equipment to enable you to develop real life prototypes as part of your project work. So for example, we have an extensive suite of 3D printers and laser cutters, amongst other things, through here. And these technicians can help you on accessing this equipment and using this equipment to create prototype pieces as part of your project work. So rather than just having a circuit board or a bit of code, you can actually have a completed package. So here we are outside the department, and we're actually centred right in the heart of the campus here. So over there is the Guild of Students. Sometimes other universities sometimes refer to this as the Students' Union. The Career Studio is just over there. As we look around, we're actually centred just opposite here, this fantastic red brick building. This was actually the first building in the university, and actually the first red brick building, university building in the UK, and where the term red brick university comes from. I'm scanning across. We have other departments nearby, so we have computer science there, who we work closely with in some of our degree programmes, and just the other side of them is engineering, where you may spend some time if you're on a mechatronics or an avionics course. And then we have one of the two libraries in the university based just there. So right on our doorstep for you to be able to make full use of the facilities that the university has to offer.